Hey, great to see you again. So now we're gonna go over linear programming. Linear programming is a very exciting thing, right? Is a method that we can use not only operations, it's a mathematical modeling that you can use in any area and any business. So it could be useful in your or career. So I'm gonna start talking about linear programming with a specific problem, okay, that I want you guys to think about. Okay. So let's say that you're going to camp and you have to choose items to place in your backpack. Each has specific weight, volume, and calories that you need to bring. But you only have 45 cubic inches of volume available and 2 pounds of weight. So which ones would you bring? And let's say that you cannot bring, multiple items. You can only bring one of each one of them, or it can be zero or one of each one of them. And then you have the sandwich, yogurt, chips, cereal, eggs, and half of a chicken. And here, how many cubic inches each one takes, what is the weight that each one takes, and how many calories they have. Okay? And the problem here is we need to maximize the amount of calories. We need to bring as many calories we can. Okay? But there are limitations. So there's the volume limitation and there's the weight limitation, right? And you can choose different ones. So if you think about it, there's tons of different options that you can try, right? I can do this minus this. I can do yogurt or sandwich and chicken, and then when you're trying those different options, you get to a limit, right? You get, oh, now it's too much weight, now it's too much volume. Okay, so what I want you guys to do is try to do this, okay, at home, and bring it to the class. I'm not going to give you the answer for that one. You bring to the class, and we're going to discuss that in class. I'm going to see who of you guys got it and how many calories maximum you can bring. And I'm showing this example because this is a very classic example. This example have more than 100 years, okay? And that was the start of the whole linear programming, and there's a bunch of people that study that. It's based on mathematical modelings again, but it can be used in any kind of situations, right? Where we have to maximize or minimize something, okay? And we have tons of different options, right? So imagine that you're in the finance business and you want to know, oh, how do I minimize the risk of different investments? How do I maximize the revenue, but at the same time, I don't want the risk to be more than this or that, or I don't want to spend more than this or that. So you can have, or I say, oh, I don't want to have more than 30% of my investment in bonds or whatever it is, or treasure titles, whatever it is, right? So set this limitation, but you have to optimize something, right? The same thing with marketing. How I'm going to spend money to maximize my, let's say, how many people I can reach. But then I have budget constraints, and I want to do multiple channels, and I want to do online. So there's tons of different decisions. You can put this into a model and it gives you the best answer, and that's the magic of linear programming. It gives you the best answer without trying and error, right? So for this model, you need to do try and error. You need to spend some time there and crack your head a little bit, see if that's working, and then bring it to class. Okay, and we're going to discuss that. So what is linear programming? It's a technique that allows you to find the best option, right? With some limitations, right? So the best option, and we have some limitations that we're going to call them constraints, okay? And we're going to look how they. And now let's see what is it. What is the kind of important things that we need to learn first? Objective function. Okay, objective function is the thing that I want to minimize or maximize. So it's an equation that I'm going to write, and I'm going to say what needs to be maximized. So usually we're talking about maximizing revenue or maximizing profit or minimizing cost and the problems that we're going to talk about. Okay, but you can do that to any kind of math, right? That you can write down into a math problem. The decision variables are the things that you're going to decide. Okay, so I need to maximize something. What is the example? What we need to maximize? Calories, right? We need to maximize calories. And there's a function for that. How am I going to write how many calories I have? Well, it's going to be every time that I have a chicken, it gives me this amount of calories. Every time that I have an egg, this amount of calories. Every time that I have a sandwich, this amount of calories. Okay. what is going to be the decision variable? So decision variables are what I'm deciding on. So I have the function, the equation, that is what I need to maximize. And what are the decisions that we're making on the knapsack example. So we're deciding if we're going to bring sandwich, yes or no, yogurt, yes or no, chips, yes or no, cereal, yes or no, egg, yes or no, or half of a chicken, yes or no. And that's what we're deciding. Okay? And for each one of them, I'm going to decide if I'm going to bring it or not. And that's what we're doing, right? So we have here 1, 2, 3, 4, 5, 6 decision variables. I'm deciding if I'm going to take them, yes or no. Okay, it's a binary decision. It's a little bit different. We're not going to go into these specific cases, but just for you guys to understand what does that mean. So they're decision variables, and we have our constraints. Okay, so what are our constraints in the example of the knapsack? It's going to be the weight and the volume, right? So I only have two constraints. Weight have to be less than 2 pounds, if I'm not mistaken, and volume I think is 45. And then these are my constraints. So I can write down also in an equation. I can say, okay, for every chicken, let's say the chicken that I take, half a chicken is going to take 30 inches and 1.1 in weight. Every egg is going to take 4 and 0.11. And I can write down the equation for volume then to look if I'm actually reaching that maximum yes or no. So that will give me my constraint, and I know that I can kind of juggle with the decisions and try to understand how that impact in my constraint. Okay. Now we have parameters. So these are the coefficients. So my equations, they have coefficients. So for every half a chicken is going to be 30 cubic inches, I think. And then for every sandwich is going to be X amount of cubic inches. So that number, okay, or the coefficient are called the parameters. Linearity. So my equations are linear, means that every time that I'm going to add 1 unit, it's going to multiply by a number. So it's a coefficient, like you're just going to multiply by 2 and multiply by 10. So if I have 1, if I have a 2, if I have 3, if I have 4, it's just going to multiply by a number, and that will be linear, right? Because it's increasing in the same amount of increment, in the same increment. And non-negativity means I cannot have a -1 chicken, so I can have more sandwiches or yogurts or whatever it is. So the values have to be 0 or positives, right? And now we're going to get to the steps of the linear programming, and there are 3 steps. First, I have to define my decision variables. So I need to find out what I'm deciding on. I'm deciding in how many pounds of this I'm producing, how many units of this I'm producing, or this model or this model. Or in this case, I'm deciding if I'm gonna bring a chicken, yes or no. I'm gonna bring a yogurt, yes or no. These are my decisions that I'm making, right? So I need to just find out what are the decision variables. That's the first step. Second step, find out the objective function. Write that down. How does the objective function look like? And my decision variables are going to be in my objective function, because if I decide to bring a chicken, I'm going to increase calories. If I decide to bring a sandwich, I'm going to increase calories, right? So this is going to impact in my objective function, right? Which I'm want to maximize or minimize, right? And finally, I write the constraints. So constraints are the limitations. Again, if I decide something is going to impact in at least one of my constraints, right? In terms of the example, if I want to bring half of a chicken, it's going to impact in the first constraint, which is the volume, and it's going to impact the second constraint, which is the pounds, that I'm maximum amount of pounds, right? So my decision is going to impact in those 2 constraints, so I need to write those constraints. And next video, we're going to see an example about how to do that.